Hi students, you've been working on your condensation reading, and I asked you to do the main idea, a picture in your head, and now I'm going to show you the actual picture for each one of these. The first one is convective uplift. Convective uplift is just like convection that we've been talking about all year. So for convective uplift, the surface of the earth is warm, just like the bottom of our lava lamp. As the air warms, the particles become less dense, so they begin to rise. But as they go up into the atmosphere, those particles become denser because they're colder, and obviously we see this cloud and we're eventually going to have rain. So the warm air is heated at the earth, at the bottom, just like a lava lamp. As the warm, less dense air rises, it eventually cools and becomes denser. And obviously that air is going to go right back around, just like we've talked about. So that's convective uplift. The next one is frontal or convergent uplift. Now, this can be two very similar things. So, for frontal wedging, this is what frontal wedging will look like. And in Michigan, we obviously see this a lot. This is where two fronts meet. So we have warm air colliding with cool air. Now, I always feel in Michigan, the cool air is always the bully, so it usually will cause us to have a cold front. But the cold air comes in, and since it's more dense, it's the bully, it causes this warm air that's less dense to uplift, okay, and then the cool air will move in, okay, so we had our warm front, and then the cool air comes in and bullies that warm air out of the way. It can also look like this for convergent uplift. When we have two warm air masses coming together, it's kind of like a convergent boundary, where neither one wants to subduct, so they both uplift. And as they uplift, they become cooler, because we know our atmosphere is cooler the higher you go, and will come up, condense, and eventually we'll have some rain. So both of those are the same. We both have this convergent boundary where two air masses are coming together. This one's showing where two warm ones come together, and then the frontal wedging was showing the cold and warm. The next one we have is orographic uplift. Now, we don't experience this very much because we don't live by the mountains. But what happens is when we have the warm air coming through, it uplifts because it's less dense, and it obviously condenses, and then it will rain. So the left side of the mountain is usually rainier and cooler. And you can see that it says rainy and cool. You might want to even draw some raindrops right here. On the other side of the mountain, it is warm and dry. And that is because all this rain has dropped here, and by the time it moves over to the other side of the mountain, we have warm, dry air. Okay? So when warm air collides with the mountain, it uplifts and it's cooled, and then it condenses, and this is the windward side of the mountain. And then after the rain happens, that air continues to move over the mountain, and this side, the leeward side, is warm and dry. Know for your test and your exam that the windward side is rainy and cool, and then after that rain is dropped, the leeward side is warm and dry. Now, for your adiabatic cooling, all air wants to move from a high pressure area to a low pressure area. And I know this isn't a very good picture, but you'll understand it. So inside a balloon, especially one that's completely filled, the particles are very close together. They're in a high pressure area. So when we pop a balloon or we let the air out because we didn't knot it, the air automatically wants to go from this high pressure area to a low pressure area. And you can see that the particles are spread out, so obviously they're going to feel a lot better. So the high pressure area is inside the balloon, and they want to go from a high pressure area where they're all crowded on top of each other to a low pressure area. When that air comes out, it actually feels cooler. Now there really is no cooling going on, but because it's moving from high pressure to low pressure, it actually will feel cool if you put your hand by the opening of that balloon. So that's adiabatic cooling. So you'll need to know all of these uplifts for your exam and for your test for this section.